Dear friends, today in this video I would like to share some information about grinding machine and grinding operation. So here grinding is one of the important machining operation which uses abrasive machining methods. So here abrasive particles are used for machining the surface of the workpiece. That means here very thin layer of material is removed. That means the metal removal rate is very small, but as the metal removal is as particles or powders or dust particles, the surface generated will be having good surface finish. So the particles removed are around 250 microns to 500 micron size. Grinding can be defined as the material removal process by using abrasive action between a rotating abrasive wheel or grinding wheel and the workpiece. Grinding machine is a power operated machine tool where the workpiece is fed against a constantly rotating abrasive wheel or grinding wheel. So working principle of grinding machine. So the figure shows the sketch. This is the this circle indicates the grinding wheel. This is the grinding wheel, and this is the workpiece, rectangular workpiece, which is on a table. And grinding wheel is always rotating. On its cylindrical surface, there are a lot of abrasive particles. So when it touches the surface of the workpiece, because of the abrasive action, because normally the abrasive particles are harder than the work surface, so that will plug out the material or will remove the material like powder material from the surface of the workpiece. So that is the working principle. So here also the shearing takes place because of the hard particles, sharp cutting edge particles of the grinding wheel. It will, just like a cutting tool, it will act on the workpiece, and the material will be removed as powder chips with minor particles, and we can cover the entire surface by giving two types of feeds, that is longitudinal feed and cross feed. So the vertical feed is also possible by moving the axis of the spindle of the grinding wheel. So this is the depth of cut. So the grinding wheel consists of actually it consists of three types of material. That is two types of material: one bonding material and the abrasive particles or abrasive materials. And abrasive materials are bonded with strong bonding like cement or this cement type of material. Resins etc. can be used as a bond, and that will mix with the abrasive particle, and we are casting the grinding in the required shape. So it is only economical method of cutting hard materials. So that is another applications. It is a finishing operation. Also, this grinding operation is used for machining hard surface. It produces very smooth surface, very suitable for finishing operation. Surface pressure is also comparatively minimum, so that no need of holding firmly the workpiece, or we can machine very light small workpiece on this grinding machine because there is no much force exerting on the work surface. So these are the three major advantages of the grinding process. So this is the theory or the mechanism of cutting. You can see these are the abrasive particles. These are the abrasive particles on the grinding wheel. It's a circular grinding wheel, and this white portion is the voids, and this black is actually the resins or the bonding materials. So this is properly mixed with this one, and the important thing is The specification of the grinding wheel is very important, and it is specified based on the number of abrasive particles and the size of the abrasive particles and the type of bonding and the size of the grinding wheel. So these are all will influence the grinding process. So based on the type of material or the workpiece, we have to use different types of grinding wheels. That means certain material cannot be used for machining this. For example, these abrasive particles are of different types. So normally used abrasive particles are the sand, silicon carbide, aluminum carbide, etc. are the abrasive particles used for this grinding wheel. And the bonding materials are cement and resins, etc. are also used for bonding. So this is the direction of rotation of the grinding wheel, and this is the feed direction of the workpiece against the rotation of the grinding wheel. The classification of the grinding wheel based on the construction and the type of surface used. Bench grinding machine, surface grinding machine, cylindrical grinding machine, centerless grinding machine, internal grinding machine, and a special purpose grinding machine. So we'll discuss one by one. Surface grinding machine. This is used for machining horizontal surfaces. Horizontal surface, and sometimes it can be used for angular and contour surfaces. So for angular and contour surface, we have to use the different shapes of grinding wheels. So the cylindrical grinding wheel is widely used for generating the flat surfaces. So in this schematic sketch, you can see the grinding wheel which is rotating on a horizontal axis, and this is the workpiece which is on the table. So the table can have a longitudinal movement and a cross movement, and the grinding wheel is rotated in the horizontal axis with a high speed. So when it touches the workpiece, it will remove the material from the surface. So we can cover the entire surface by giving longitudinal and cross feed. So this is the side view of this sketch. So the surface grinding machine. This machine may be similar to the milling machine, used mainly to grind flat surfaces. Basically, there are four different types of surface grinding machines. That means the different structured machines are available. Horizontal spindle and reciprocating table. That is one type. Another one is vertical spindle and reciprocating table. The third category is horizontal spindle and rotary table. The fourth one is vertical spindle and rotary table. So these are the different combination of the machine. So here you can see this is horizontal spindle and a reciprocating table. So this is the spindle. It is on a column, on the column of the machine. All the mechanism of and the drivers are incorporated in this column, and this is the spindle, the axis of the spindle. At the end of the spindle, you can see the grinding wheel which is rotating. So A is the grinding wheel, and this is the workpiece. This is the workpiece which it is kept on a table. So normally the table is having electromagnet, so that just keep the workpiece on the table. No need of other mechanism, holding mechanism is required. And this table can have reciprocate, so it can reciprocate in the longitudinal direction. Also we can give cross feed, that is in the perpendicular to the longitudinal axis we can give a cross feed. So by both these movements we can cover the entire surface of the workpiece. And suppose you want to give a feed, that is a vertical feed, two possibilities are there. In some machines we have vertical feed also on the table, and some other design the machine is having the spindle can move up and down. That means the grinding wheel can have a vertical movement. So both are possible. So this sketch will explain how the metal removal takes place. That this is the grinding wheel which is rotating in the anti-clockwise direction, and this is the workpiece which is fed against the rotation of the grinding wheel, so that because of the abrasive action, the metal will be removed from the surface. Now we'll see another type, that is the vertical spindle. The table is same. The table is reciprocating, but the spindle is vertical, just like vertical milling machine. And at the end of the spindle, you can see the grinding wheel which is rotating. And here, the cutting action is because of the end face of the grinding wheel, not the cylindrical surface. So here you can see how this works. So this is the bottom of the grinding wheel, which is actually cutting the material from the surface of the workpiece. So the workpiece is reciprocating. This is always rotating on the vertical spindle. So you can give the feed by moving the table, so the entire surface can be covered. This is another type. Here the spindle is horizontal. That is horizontal spindle, but the table is rotating. It's a circular table, rotary table. So in addition to the rotation of the table, we can have translatory motion also. Reciprocation is also available for this table. So this is the workpiece. You can see this is the workpiece which is on the table, rotary table, and this is the grinding wheel which is rotating in the horizontal axis. And by moving the table while and rotating the table, we can cover the entire surface of the table. Entire this area, this circular area, can be covered by the grinding wheel, so that wherever you keep the workpiece, that can be reachable for this grinding. So one of the advantage of this one is the round table is advantageous because if there are a lot of identical parts, if you want to machine simultaneously, just to keep all the parts, just like bushes or washer, etc., just to keep on the table, and the table is slowly rotated. So table is slowly rotated, and the can give the feed, vertical feed on the grinding wheel, so that the entire parts will be machined simultaneously with the same depth of cut. So you can machine the entire pieces simultaneously with the same dimensions. So that is the advantage of this round table. So the round table, the table is rotating the slow speed. Okay, this is also a round table. The difference is here the vertical spindle grinding wheel is used. Vertical spindle. So here the cutting action is because of the this side face of the grinding wheel, not the circular part or the cylindrical surface. You can see here, this is the grinding wheel which is rotating in the anti-clockwise direction. These are the workpieces kept on the table. Just rotate the table, just rotate the table slowly, so that it will test the surface of the workpiece during the travel, and that will machine the surface. So C is the down feed. So we can give that vertical feed by moving the axis of the cutter or the grinding wheel. So this is the sketch of a grinding machine, surface grinding machine. You can see here the grinding wheel on a horizontal spindle. This is the guard, and this is the vertical column where the mechanism of the operation is situated, and this is the table, the work table, and the table movement control is there. Here you can see this wheel, that is for table trans traverse, table traverse, that is the horizontal this sliding movement of the table. And this is the cross feed of the table. This is the cross feed, and this one is the vertical feed. So here the table is having 3 degrees of freedom. First one is the longitudinal feed, the other one is the cross feed, then the third one is the vertical feed. So here the table can lift up and down. So the depth of cut can be adjusted by rotating this wheel. This is the photo of the surface grinding machine. Now we'll see the cylindrical grinding machine. Cylindrical grinding machine is widely used for machining the cylindrical surface, cylindrical workpiece. Both the plain cylindrical and conical surface also we can machine by using this cylindrical grinding machine. So the figure shows the grinding wheel. The grinding wheel is a larger diameter, and this is the workpiece. Both are cylindrical shape. Both are cylindrical shape. So both are rotating in the same direction. So you can see this is rotating in the clockwise direction. The workpiece is also rotating in the clockwise direction. But the point of contact or the surface of contact, both are moving in the opposite direction. The angular velocity are different direction on both this contact surface. That is why the machining takes place when the grinding wheel touches the workpiece. This is the side view. This can be used for cylindrical surface. For machining cylindrical surface, both straight can be straight surface or curved surface also can be machined, and different contour surface can also be machined. Only the thing is we have to use the required profile. That means the shape of the grinding wheel also will change based on the shape to be obtained. The cylindrical surface grinding machine are of different types. There is plain center type cylindrical grinding, universal cylindrical surface grinding, and centerless cylindrical surface grinding machines. This is the center type cylindrical grinding machine. Here, the cylindrical object or the workpiece is held in between two centers, that is supported on both the ends. So just like a chuck is there for driving, and the other end is also supported by using a tail stroke type device, and this is rotated. So driver is used for driving this one, and another driver is used for driving the grinding wheel. This is the head of the machine, spindle head. So this is a horizontal machine. This is rotating in the anti-clockwise direction. Workpiece is also rotating in the anti-clockwise direction, but in the contact surface both will be in the opposite direction. So the machining takes place, and if you want to cover the entire length of the workpiece, just to give the feed on the table. So the longitudinal feed can be given on the table, so that while rotating itself, feed is also given, so that the entire surface can be covered or machined. The depth of cut can be adjusted by giving this cross feed, that is either on the table, or you can move the spindle head. Both are possible. So this is the schematic representation of how the center type grinding, cylindrical grinding is operated. So this is the workpiece. It is rotating in the one direction. The same direction we are rotating the grinding wheel also, and a feed is given on the workpiece so that the entire length can be covered. So this is universal cylindrical surface grinder. It uses a swivel base or swiveling wheel head and swiveling wheel head slide. So this grinding wheel head can swivel in different angles. So that is the one of the speciality of this universal cylindrical. This can be used for machining inclined or the conical surface. If you want to machine a conical surface of the cylinder, we can machine by tilting the or swiveling the head, the axis of the grinding. Then another one is special application of the cylindrical grinder. That is, for example, if you want to machine a thread, if you want to machine a thread, suppose you want to finish the thread of a bolt or a nut, you can use this type of grinding wheel. That is special type. Principle of cylindrical grinding is being used for thread grinding with specially formed wheels. So this is just like a forming operation. So here you can see a thin wheel is used, and one after the one you can machine the entire thread. That means after completing the first thread, you can machine the second one. Like that, you can continue. But this type of grinding wheel is just like a forming operations. So simultaneously you are machining and the entire thread. So here both cross movement and longitudinal movement is done But in the second case, no need of a longitudinal feed because we are using a larger threading wheel. So only cross feed is sufficient. Only cross feed is sufficient. This should be used for machining thread cutting operations. Or if you want to, this can be used for cutting thread on a workpiece, also for grinding thread, which is already made on a work surface. So both type of grinding wheels are used. So this is the cylindrical grinding machine. You can see here, this is the workpiece, long workpiece. It is held in between two centers and it is rotated. And another, this is the grinding wheel. It's a larger wheel which is also rotated on the spindle, horizontal spindle. And feed is given by moving the grinding wheel along the axis so that the entire surface can be generated. So this is the photo of the cylindrical grinding machine, and this is the centerless grinding machine. So centerless grinding machine is a different type. Here we are not supporting the workpiece on both ends. It is free. So advantage is any long slender workpiece can be machined, but it cannot be machined. The long slender workpiece cannot be machined in center type grinding cube because it is the length is limited. That means the length maximum length permitted is the distance between two centers. So if it is larger than that distance, we cannot use on a center type grinding machine. But here, whatever be the length of the workpiece, we can machine by using centerless grinding machine. The workpiece is placed on a work rest because there is no other support. Just you are keeping the workpiece on a work blade, so it is supported from the bottom. Also, it is held in between two wheels. The first wheel is the grinding wheel, larger wheel. The other wheel is the regulating wheel. Both are rotating in the same direction, but the workpiece is rotating in the opposite direction. So no power is given for workpiece rotation. Only the power is given for grinding wheel rotation. So only one motor. So this is actually pressing the workpiece. Regulating wheel is pressing the workpiece against or towards the grinding wheel, so that it will be firmly held in between this one. Also, because of the rubbing action, the material will be removed from the surface of the workpiece, and this will support that will it will prevent the falling of the workpiece in the downward direction. So we can machine curved or cylindrical surface or conical surface by using this centerless type grinding machine. So this is the three-dimensional view. You can see here this is the grinding wheel, and this is the regulating wheel, and this one is the workpiece. Number two is the workpiece. It is rotating in the opposite direction. And here the side view you can see the regulating wheel. The axis of rotation is not the horizontal axis; it is inclined to the horizontal axis, theta degree. Why this is provided? This is provided for getting automatic feed, longitudinal feed. That means if it is inclined in a certain angle, because of the because of the horizontal component of the force. So there are two components, vertical component. Because of this inclination, sine theta and cos theta is there, vertical component and horizontal component. Because of the horizontal component of the force, there is a slow movement in the horizontal direction for this workpiece. That means no need of pushing the workpiece. Just keep the workpiece in between the two wheels, and if you start the grinding wheel, slowly the workpiece will be proceeding. That means it will be moving forward. So while moving in the forward direction, the machining also takes place. So it is automatically fed. That is another advantage of centerless grinding.